Okay, class, here's a lesson on Chapter 5, Section 4, which is about multiplying polynomials. So, prior to our test, we added and subtracted polynomials, and now in the next couple of sections, we're going to multiply them and divide them. So let's hit the ground running and just get right after it. Example 1 asks us to multiply two monomials, like negative 4a cubed and 3a to the fifth. But multiplying two monomials is just like multiplying any two numbers. I mean, we've done this, haven't we? What did we say earlier in Chapter 5? Treat the coefficients like normal. Negative 4 times 3 is negative 12. And when you multiply variables, like a cubed and a to the fifth, you add the exponents. Negative 12a to the 8th. So that's not really anything new, nothing earth-shattering there. Similarly, if you had a monomial like 5x squared that you were multiplying by negative 4x squared plus 3x minus 2, here we have a monomial times a trinomial, but that's just a matter of distributing just like we've done all semester. So 5x squared times negative 4x squared is negative 20 x to the fourth. 5x squared times 3x would be 15, and we'd have x cubed. You're adding 2 and 1 on your x's. And 5x squared times negative 2 would be negative 10x squared. So the moral of the story from those two examples is if one of your polynomials is a monomial, then there's not really anything different than what we've done. Same old song and dance. But what if neither polynomial is a monomial? What if we had something like this? 3m cubed minus 2m squared plus 4, a trinomial, times a binomial like 3m minus 5. Well, you might think that it's going to be a lot different, but really it's not. This next sentence is this whole lesson in a nutshell. If you get this next sentence, you'll have the whole lesson. Here you go. To multiply polynomials, simply distribute every term in the first polynomial through the second polynomial. Every term in the first polynomial through the second polynomial. So what I'm going to do, I'm going to distribute the 3m cubed. When I get that done, I'll distribute the negative 2m squared. When I get that done, I'll distribute the 4. That's it. So let's take the 3m cubed through. If I take 3m cubed times 3m, that would give me 3 times 3 is 9, and adding the exponents, 3 and 1 would give me m to the fourth. Then I'll take 3m cubed times negative 5, which would be negative 15m cubed. And we're done with the 3m cubed. Now we'll distribute the negative 2m squared. Negative 2m squared times 3m, let's see, negative 2 times 3 would be negative 6. And an m squared and an m, if I add the exponents, would give me m cubed. And then negative 2m squared times negative 5 would give me positive 10m squared. And I'm done with the negative 2m squared. Now we'll distribute the 4. 4 times 3m is 12m. 4 times negative 5 is negative 20. I'm done with the 4, and I'm done distributing. Okay, now once you get done distributing, we're just going to combine like terms. So what have I got? I got a 9m to the 4th, and that's the only m to the 4th term I have. Negative 15m cubed and negative 6m cubed would be negative 21m cubed. Notice I'm not doing anything with the exponents there because I'm just combining like terms. I only add the exponents when I multiply. Okay, I've got this 10m squared. That's the only m squared term I have. Done with that. And 12m is the only m term I have. Done with that. And minus 20 is the only constant that I have. So there we go. 9m squared minus 21m cubed plus, I said that wrong, 9m to the 4th minus 21m cubed plus 10m squared plus 12m minus 20. Okay. Now you might recall that when we're multiplying two binomials, sometimes we use a little bit of special terminology for that. Let me show you what I mean. 3x minus 4 times 2x squared plus x. Let's distribute the 3x. 3x times 2x squared is 6x to the 3rd. 3x times x would be 3x squared, done with the 3x. Let's do the negative 4. Negative 4 times 2x squared would be negative 8x squared. And negative 4 times x would be negative 4x. And then combining like terms, the only x cubed term I have is 6x cubed. Be done with it. A plus 3x squared and a minus 8x squared would be minus 5x squared. Done with that. And then minus 4x. Okay. So there's an answer. Now, I said sometimes there's special terminology used for two binomials. If you think about it, what we just did was we multiplied the first two terms, f. Then we took 3x times x. Those are the two terms on the outside, O. Then we multiplied negative 4 by 2x squared. Those are the two terms on the inside, I. And then we took negative 4 times x. Those are the two terms that are last, L. So sometimes whenever you multiply two binomials, teachers and students sometimes use the acronym FOIL for that. And it stands for first, outer, inner, and last. Now, I don't usually think that way. I just think the way we usually do. Distribute the 3x, then distribute the negative 4, and that always gets you the right answer, whether you have two binomials or not. But this is a common phrase that's used, and we need to be familiar with what it's referring to. Sometimes you'll hear people say, FOIL let out, or when we get to factoring, we'll talk about the FOIL method. So that gives you a point of reference for when we mention those things later on. Okay, well, I really don't have anything else to show you that's earth-shattering. I do have a couple shortcuts. So we'll finish off with those. The first shortcut is for multiplying conjugates. Well, that's a new word. We haven't used the word conjugate yet. What are we referring to there? Well, conjugates are binomials. They're just alike, except for the sign in the middle. For example, 2x plus 3 and 2x minus 3 are conjugates. X minus 6 and x plus 6 are conjugates. So there's a shortcut that we can use when we multiply conjugates. Now let me just say up front, you don't have to use the shortcut. If you don't like it or you have trouble remembering it, you can always just do it the old-fashioned way. In fact, on both of these problems, first, I'm going to do it the old-fashioned way, and then we're going to see if we can figure out the shortcut from doing it the old-fashioned way. Okay, so here we go. Let's distribute the 2x. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Done with the 2x. Let's do the 3. 3 times 2x is 6x. 3 times negative 3 is negative 9. Done with the 3. Done distributing. Now, do you notice something kind of unusual happens on this problem? The two middle terms, minus 6x and 6x, cancel each other out, and I just end up with 4x squared minus 9. I wonder if that always happens when I multiply conjugates. Will the middle terms always cancel each other out? I don't know. Let's try this one down here and see if they do. Let's distribute the x. X times x is x squared. X times 6 is 6x. Done with the x. Negative 6 times x is negative 6x. Negative 6 times 6 is negative 36. Done with the minus 6. Do you see that it happened again? 6x and minus 6x cancel. And I just end up with x squared minus 36. It did happen again. Class, anytime you multiply conjugates, the middle terms are always going to cancel. So in terms of a shortcut, then what we can do is just ignore the middle terms. So to get our answer, we can always just take first times first, in this case 2x times 2x to get 4x squared, and second times second. 3 times negative 3 would have given me negative 9. That's the shortcut for multiplying conjugates. It's simply first times first, second times second. Now you can only do that if you have conjugates. If you don't have conjugates, it's not going to work. Let's see if it would have worked down here. First times first would have been x times x, which is x squared. Second times second would have been negative 6 times positive 6, which is negative 36. It would have worked. So if you get a problem that you recognize as conjugates, like let's say we had 4x minus 7 and 4x plus 7, since they're conjugates, you know you can just take 4x times 4x, first times first, that's 16x squared. And negative 7 times positive 7 is negative 49. And you're finished. Okay, that's the beauty of the shortcut. It shortens up the process a little bit. So either use the shortcut or don't. It doesn't matter. If you want to do it the old-fashioned way, that's fine. But it's available to you if you want it. Okay, the second shortcut that we're going to look at is for squaring a binomial and that is what it sounds like. We're taking something with two terms, a binomial, and squaring it. And we're going to have a shortcut for this. Now, if we were working this problem the old-fashioned way, the only way we have to do this right now would be to actually take m plus 7 times m plus 7. I mean, that is what it means to square m plus 7, right? Take it times itself. Let's see what happens there. M times m is m squared. M times 7 is 7m. Done with the m. Let's distribute the 7. 7 times m is 7m. 7 times 7 is 49. Done with the 7. So what do we have now? We have m squared plus 14m plus 49. Okay, let's take a look at that problem a little bit. On that problem, the two middle terms didn't cancel. On that problem, the two middle terms were the same thing. It was 7m and 7m. So, let's see if we can parlay this into a shortcut then, if we look for the pattern there. Let's see. This m squared would have been m times m. So the first term is going to be first times first. What about the 14m? Well, that came from 7m plus 7m. And both of those 7m's came from multiplying the first times the second. So to get the 14m, we could have taken the first times the second and then doubled that, because you're going to end up with two of them, just like we ended up with two 7m's. And then the 49 we got by taking 7 times 7, so it will be second times second. So here's your shortcut if you want it. First times first, first times second times 2, and second times second. So let's try that on another problem here. Let's say we had 2p plus 3v squared. And we said, okay, I'm going to try the shortcut because I'm squaring a binomial. So, step 1, first times first, would be 2p times 2p. That'd be 4p squared. Step 2, first times second, and then times 2. Well, if I take the first, 2p, times the second, 3v, I'm going to get 6pv. And then if I take that times 2, I probably shouldn't use that x there. That's kind of confusing. Let's do it this way. If I take that times 2, I'll get 12pv. And then finally, second times second would be 3v times 3v, or plus 9v squared. Boom. There's that problem using the shortcut. Now, if you don't like the shortcut, or you think you're going to have a hard time remembering it, remember you could always do it the old-fashioned way. Take 2p plus 3v times 2p plus 3v, and we'll do it the old-fashioned way here to show that you're going to end up with the same thing. Okay, so let's do that. 2p times 2p is 4p squared. 2p times 3v is 6pv. Then with the 2p. Let's distribute the 3v. 3v times 2p is 6vp, but I'm going to write it as 6p PV, I like to keep my letters going in the same order so that it's easier to recognize here in a moment that we're going to have like terms right there. If one of them's a PV and the other one's a VP, it's harder to recognize. So what I usually do is put the first letter in the alphabet first and the second one second. Okay, and then 3V times 3V is 9V squared. And now we can finish by combining like terms. So I got 4P squared. 6PV and 6PV make 12PV plus 9V squared, which is the same thing that we got here earlier. Same thing. Okay, so we need to make sure that we're good at multiplying polynomials because A, we do it a lot, and B, it's foundational to understanding factoring when we get there. So here is your assignment for Chapter 5, Section 4. On page 299, let's go 6 through 24, 43 through 50, and 89 through 94.